episode 30. This is part 3 of chapter 12, A Physicist's History of Bad Philosophy, with some remarks on bad science. And today, we're going to be spending a little bit more time on the bad science aspect of the chapter. Now, when it comes to bad science, as we indicated at the end of the last section, at the end of the last part that I did, part 2, really what we're talking about is explanationless science. There's studies that you can do, investigations, experiments if you like, that can purport to show correlations between variables. Now, an investigation that purports to find a relationship, a correlation between two variables, it might be interesting, but unless we have a causal mechanism whereby one variable causes another variable to increase, whereby an increase in one variable causes the increase in another variable, we have an explanation as to what that cause is, we have explanationless science. Now, there are many examples of explanationless science. David's going to use behaviorism as an example, really, of explanationless science, but there are other kinds. For example, in the area of public health, I can't remember precisely when the study was, I'm sure I could look it up now, but back in the 80s approximately, there was a study purporting to show that the closer someone lived to a power stanchion, the worse their health outcomes were. And so this is explanationless science. Until we have an explanation why proximity to a power stanchion causes poor health outcomes, we don't have a scientific theory. All we have is a correlation. There could be a third factor. Now, in this case, it is true. I think in certain areas of America, the closer you live to a power stanchion, the more likely you are to have a lower life expectancy. And so many people at the time interpreted this as meaning there are electromagnetic waves coming out of those power stanchions, affecting people's DNA, causing cancer, causing other sorts of health problems. And so this was the reason why one wouldn't want to live near a power stanchion. Now, physicists kind of knew that the electromagnetic radiation coming from a high voltage power stanchion is usually very low frequency indeed. You might get some radio waves, but we have an explanation as to why that can't cause ionization of atoms in the DNA and therefore cause mutations and therefore cause cancers. So we had an explanation of that. A good explanation, in other words, as to why the power stanchion itself was not causing the worst health outcomes. The better explanation, as it turns out, is that people who live close to power stanchions live in houses where the land value is lower. People don't want to live near power stanchions. Real estate agents have difficulties selling houses around power stanchions because you've got this big, ugly tower in your backyard, ruining the view, taking up space, whatever. It causes the value of the land to go down, possibly for irrational reasons. But if that's the case, people who live in those areas can't afford better healthcare. And because they can't afford better healthcare, that means that their health outcomes are generally going to be worse. Had nothing to do with radio waves or other kinds of energy coming from the electrical wires. So this is a case where we can have a very good correlation between two things, and yet one does not cause the other. There's a third factor. And that third factor actually means that you can't extrapolate. You can't use that relationship to make useful predictions. Without an explanation, there's no possibility of making predictions. A prediction would mean that you'd be able to take a particular person living in close proximity to a power stanchion and be able to determine that that person is more likely to have worse health outcomes. However, we could falsify this in many different ways. There would be people who do not fit the trend. Once you have people that don't fit the trend, another word for that is a falsification of the theory that power stanchions cause bad health outcomes for people. Now, similar kinds of bad science happen everywhere. Not so much in the physical sciences, and we'll get to the reasons why, and it's got to do with uncertainty analysis, or being able to quantify your errors, or at least being able to say what the likely sources of error are going to be in your study. But in other areas of science, let's say environmental science, there could be all sorts of ways in which we could find a correlation between, say, increasing average global temperatures and all sorts of supposedly bad environmental effects. Species decline, increase in wildfires or bushfires, increase in hurricanes or tornadoes, increase in desertification, decrease in corals, etc., etc., etc. Now, there may be mechanisms for some of these things, but I'm not too sure whether or not the mechanism for all of these things must come down to an increase in the amount of carbon dioxide in the atmosphere at any given time. It could be that these things are caused by something else. It could still be due to climate change, but perhaps by some mechanism other than the increase in carbon dioxide emissions, let's say. So David has come to the point in this chapter where he's talking about the fact that in behavioural studies of people's psychology, typically what is done is that surveys are conducted or people's behaviour is monitored, and that behaviour might include things like marking checkboxes on a survey. And these survey responses might be used to determine whether or not someone is suffering from depression or whether or not someone is functionally very happy or not. And then some kind of genetic study might be performed, and we might find a correlation between genes or genetic similarities between people and their tendency to report themselves as having high levels of happiness, let's say. But of course, marking checkboxes on a survey isn't really measuring happiness. It's not an objective measure of happiness. It's a subjective measure on the part of the person, on the part of the subject, of their own internal conscious states. And as we mentioned in the last episode, different people might have different standards for feeling precisely the same way. So two people, even though they're both saying that they feel a happiness level of 6 out of 10, they both might actually feel, in reality, quite different. And on the other hand, of course, two people who feel exactly the same, subjectively speaking, we've got no access to someone's subjectivity at the moment except via this proxy of marking a survey, making marks on a survey. Two people that feel actually, in reality, ontologically the same, might in fact report different levels of happiness. One might say they're only a 3 out of 10 because they expect that life could be a lot better than what it is. But on the other hand, someone might mark for exactly the same sensations that they've got in terms of their physiology, they might mark themselves 7 out of 10, simply because they've got different standards. And why might people have different standards? Well, some people could just be real pessimists and some people could be real optimists. And that could be because of what they know about reality as well. Now, David's about to get to the point where he's talking about the fact that there can be scientific studies, quite rigorous scientific studies, where the marking of checkboxes is perfectly valid. It's not valid in that case where we're just talking about people reporting on their own internal subjective states. Unless we can have a ruler or a thermometer or some sort of objective test as to what's going on inside of that person's subjective mental experience, we don't have access to that person's internal subjective experience. All we have access to is their reporting on their internal subjective experience. This is not typical science. We wouldn't go to a physicist and say, how did the temperature of the water feel to you? Just describe it. No, we don't want them to say, it felt really hot to me, or it felt cold to me, or it felt approximately 25 degrees Celsius to me. We want a thermometer reading. We want an instrument to be able to have access to that water and not merely to have the physicist or the chemist or whoever it is reporting on how they felt at the time. That would be rejected in any other area of science. But of course, in psychology, this is de rigueur, this is typical, this is what people do. And I guess to some extent they're doing their best. They don't have anything else. And they're doing something, but we can't say they're doing good science. So let me read from the beginning of Infinity. And I'm up to page 317 for anyone who's following along. And David writes, there are circumstances under which there is a good explanation linking the measurable proxy, such as marking checkboxes, with a quantity of interest. And in such cases, there need be nothing unscientific about the study. For example, political opinion surveys may ask whether respondents are happy with a given politician facing re-election under the theory that this gives information about which checkbox the respondents will choose in the election itself. That theory is then tested at the election. Pause there. My reflection. So this is the whole idea of pre-polling or polls in general. Maybe not exit polls, because David's there talking about beforehand, before the election, testing things before I suppose it could be done after the election as well. And notoriously these days, our understanding of polling has really been pushed around, the validity of polling. One reason is, of course, that people are it would seem possibly embarrassed to tell pollsters how they really feel about certain candidates. In some cases, they might actively be lying to the pollsters for a whole bunch of reasons, which would make polling quite unscientific. So in fact here, this idea actually presumes that people are honestly reporting on the survey about the politician. If you ask whether you would vote for John Smith, if a random pollster, say, stops you in the street or calls you on the phone and says, how do you feel about John Smith? And you say, very good. Will you be voting for John Smith? And you'll say, absolutely. It might very well be the case that you're just saying that in an attempt to appear to have an acceptable opinion to the pollster. This appears to be a factor these days. It's a new phenomenon, so far as I know, people being embarrassed or concerned about how they might be viewed by the pollster. And this goes some way to explaining why polls are no longer completely reliable. And so we've seen that for the last few elections anyway, the last few major elections in the Western world anyway. People being concerned about how they appear to a random person who's asking them how they feel about particular politicians. Now, putting that aside, okay, so putting that little quibble aside, it otherwise might be the case that certain surveys can be perfectly scientifically valid. But as David says, there is no analogue of such a test in the case of happiness. There is no independent way of measuring it. Another example of bona fide science would be a clinical trial to test a drug purported to alleviate particular identifiable types of unhappiness. In that case, the objective of the study is again to determine whether the drug causes behaviour, such as saying that one is happier, without also experiencing adverse side effects. If a drug passes that test, the issue of whether or not it really makes the patients happier, or merely alters the personality to have lower standards or something of that sort, is inaccessible to science until such time as there is a testable explanatory theory of what happiness is. Pause there, my reflection. So this is an interesting point that David's making there about, let's say, antidepressants. So do antidepressants actually cause the person who's taking them to, in reality, experience greater levels of happiness? Or is it the case that it makes the unhappiness that they tend to feel more tolerable? And so it's very difficult for the person to probably be able to distinguish between these two different cases. Perhaps impossible. Certainly for the person doing the study, it will be difficult to determine whether or not they've lowered their standards or not. And so filling out a survey or reporting to the doctor that they feel better, that they feel like their depression has been alleviated, could be a consequence of them actually feeling more happy in reality. Or it could be the fact that they don't feel, in truth, happier in reality. It's just that their standards have been lowered. Now, are these two things the same in reality? No, because there is ontologically some reality of a state of happiness. Now, we don't know what that is scientifically, but it must be the case that there are, in objective ontological reality, what's going on inside of your mind can either be very, very happy or extremely unhappy and anything in between. And how you then feel about that state, let's say that you are objectively on happiness level state 9, ontologically speaking. Sam Harris likes to speak about this. So there is a reality to your subjectivity, and Sam Harris gets this from John Searle, I think. And so this is where it really comes into its own, this distinction, this way of speaking about subjectivity and objectivity. Now, your consciousness has real existence. It really exists, unless you're Daniel Dennett, of course, and you argue that you have no such consciousness. Nonetheless, I think there's consciousness. I think most philosophers believe that there is consciousness, know that there is a kind of consciousness. We don't know how to replicate consciousness. We don't have AGI yet. Nonetheless, consciousness exists. And if consciousness exists, and if conscious states therefore exist, then there is a way of determining that some are objectively better than others. This conscious state of suffering is objectively worse than this conscious state of feeling joy, let's say. And there might be different levels of joy or different levels of happiness. Now, given that's the case, if you are objectively on happiness level 4 out of 10, that's objectively where you are, then you will also have a theory about how happiness level 4 exists. You might not know exactly what happiness level 4 feels like. Now, this is where it gets a little bit weird and complicated, but if we had a scientific theory of subjective states, of consciousness, then in some far distant future, we might know what happiness level 4 for a human being feels like. Now, when you are asked by the doctor, how do you feel on a scale of 1 to 10, even though you actually, in reality, occupy happiness level 4 at that particular point, you might say, I feel like a 3 out of 10. Now, you'd be wrong about that, but you've got some access to how you feel. Now, you're just making an error. You're making an error because you don't have an objective way of measuring your own happiness and unhappiness on a scale of 1 to 10. Now, when you take an antidepressant, it might be the case that it elevates you from what is in objective reality a 4 out of 10, what you have reported as being a 3 out of 10, it might actually raise that to a 7 out of 10. And you will report that having taken the antidepressant, you might report that it has actually alleviated your depression. It has actually raised your level of happiness. And you'd be right about that. But you'd be wrong about, of course, having claimed that you were on happiness level 3 to begin with. Actually, you were a 4. Now, there is another alternative, of course, that in fact what the antidepressant does is has no effect whatsoever on the objective state that you occupy. You remain at happiness level 4 in reality. In objective reality, you're still on a 4, but it causes you to think, to change your opinions about what happiness level 4 feels like. And so you will then report a 7, so it causes you actually to increase your errors. Now, you go and fill out the survey of 7 out of 10, and in both cases, the first case where in reality you've been raised to a 7, but the other possibility is, of course, that your happiness level has not been raised, your depression has not been alleviated, but behaviorism, effectively, the antidepressant has worked because you're no longer saying you're depressed, even though nothing much about your brain chemistry, so to speak, has been changed. Although, I know in reality, SSRIs, serotonin-specific reuptake inhibitors, I know that they actually do alter brain chemistry. All that aside, let's go back to the book. David writes, in explanationless science, one may acknowledge that actual happiness and the proxy one is measuring are not necessarily equal. But one nevertheless calls the proxy happiness and moves on. One chooses a large number of people, ostensibly at random, though in real life one is restricted to small minorities such as university students in a particular country seeking additional income, and one excludes those who have detectable extrinsic reasons for happiness or unhappiness, such as recent lottery wins or bereavement. So one's subjects are just typical people, though in fact one cannot tell whether they are statistically representative without an explanatory theory. Next, one defines the heritability of a trait as its degree of statistical correlation with how genetically related the people are. Again, that is a non-explanatory definition. According to it, whether one was a slave or not was once a highly heritable trait in America. It ran in families. Now, I'm just going to read that short paragraph again because we're going to come back to it. And I think it's something that people tend to miss in this chapter. So I'll say it again. One defines the heritability of a trait as its degree of statistical correlation with how genetically related the people are. Again, that is a non-explanatory definition. According to it, whether one was a slave or not was once a highly heritable trait in America. It ran in families. More generally, one acknowledges that statistical correlations do not imply anything about what causes what, but one adds the inductivist equivocation that they can be suggestive though. So just pause there. I'm just wanting to emphasize here, what David's doing here is he is kind of setting up how it is that you go about performing a scientific study that is a scientific study in form only. It's not scientific in the sense that you're producing good, hard to vary explanations in science. This is the way you go through and you just go through the formal process of appearing to do science, of appearing to do an experiment, of finding a correlation, let's say. But at no point are you going to suggest that this thing causes that thing or that, or if you do, you're going to equivocate about it. David continues. Then one does the study and finds that happiness is, say, 50% heritable. This asserts nothing about happiness itself, until the relevant explanatory theories are discovered at some time in the future, perhaps after consciousness is understood and AGIs are commonplace technology. Yet people find the result interesting because they interpret it via everyday meanings of the words happiness and heritable. Under that interpretation, which the authors of the study, if they are scrupulous, will nowhere have endorsed. The result is a profound contribution to a wide class of philosophical and scientific debates about the nature of the human mind. Press reports of the discovery will reflect this. The headline will say, "New study shows happiness 50% genetically determined," without quotation marks around the technical terms. Pause there, my reflection. All you need to do is to go to Google and look up or do a Google search on happiness genetically determined or something like that. And you will indeed find studies precisely of the kind that David has talked about there. David continues. Suppose that someone now does dare to seek explanatory theories about the cause of human happiness. Happiness is a state of continually solving one's problems, they conjecture. Unhappiness is caused by being chronically balked in one's attempts to do that, and solving problems itself depends on knowing how. So, external factors aside, unhappiness is caused by not knowing how. Readers may recognise this as a special case of the principle of optimism. Pause there, my reflection. So, as David is sort of hinting at here, we might very well interpret unhappiness as being about not knowing how to solve the problem of not being happy. Not being happy is a problem. If you could solve that, then that would be the solution to unhappiness. That's how to be more happy, to continually solve your problems. Usually, of course, the problem is not just this generic thing of I just want to be happier. It's a particular thing. How to solve some particular problem, like if you're chronically in pain and you don't want to be, if you could solve that, then you would be happier. If you have an illness that there is no cure for, you're unhappy until such time as you're cured of it. You're on your way to work, you're already running late and you've got a flat tire. Until such time as you are able to fix the flat tire, then you're more unhappy than you otherwise would have been. So this can be what unhappiness is. Now, of course, many people do say that there is this very real state of being depressed when everything appears to be going right in one's life, but nonetheless you still feel unhappy. What would be the view of this kind of philosophy for that kind of state? Now, it might very well be that it could be a chemical imbalance, but it could also be simply that you don't know what the problems are that are causing you unhappiness. It could be unconscious states. It could, of course, be poor chemistry in your brain, in which case it still comes down to the fact that you don't know how to be more happy. And it might be that you need to fix this chemical imbalance in your brain. I wouldn't say that that would be the solution to every single form of what is called depression in psychological science. It's more likely to be the case that there's going to be perhaps things one is not fully aware of, things one is not fully thinking clearly about that is causing the unhappiness. And if those things could be identified, and this is where psychology really is important, then the unhappiness could be cured. Things like cognitive behavioral therapy, things like any kind of talk therapy, speaking to a psychologist, are certainly going to help people who are chronically unhappy or depressed. It still comes down to not knowing how to solve the problem of unhappiness, because it might be the case that one does not know why one is unhappy. It's about knowledge. It's never not about knowledge. It's never about simply denying the fact that there is a solution involving an explanation as to why one's mental state is the way it is, and is the way that it is in a way that one doesn't want it to be. Okay, so continuing at the beginning of Infinity, and David's talking about this study that shows a correlation between unhappiness or happiness and certain kinds of genetic predisposition towards the happiness or not. David writes, interpreters of the study say that it has refuted that theory of happiness. That theory of happiness being that happiness is a state of continually solving one's problems. At most, they say, 50% of unhappiness can be caused by not knowing how. The other 50% is beyond our control. genetically determined, and hence independent of what we know or believe, pending the relevant genetic engineering. Using the same logic, on the slavery example, one could have concluded in 1860 that, say, 95% of slavery is genetically determined and therefore beyond the power of political action to remedy. Pause there, my reflection. This is a really powerful point. Many people, and it is a huge area of popular science right now, seem to think that if something has a genetic component, then that means it must be genetically determined. That if there is some gene for a thing, then there is no way in which, or if there is some gene implicated in a particular feature of humanity, then there is no way that that can be changed except via genetic engineering. But this is a perfect refutation of that. It is the case, it simply was the case historically, that in the United States, that you could do a genetic study, you could use modern methods of assessing the DNA of people and find that there is indeed a genetic component to being a slave. But this does not mean that it was genetically determined, that it was necessarily the case. Because necessarily means it was unavoidably the case, in much the same way that it's necessarily the case that element number 6 on the periodic table is carbon. Okay, that is a scientifically necessarily determined thing. Or that force equals mass times acceleration, a necessarily scientifically determined thing. Well, this is not the case with slavery. Slavery was the result of a particular, very poor moral and political theory about human beings. Typically, white people from London did not find themselves slaves in the south of the United States. There was a genetic component here, but this does not mean it was determined to be the case. Any number of scientific studies could have concluded this. And indeed, the problem of slavery of that kind was indeed solved. But it wasn't solved by genetic engineering. It was solved by people knowing better, learning better, creating the relevant moral knowledge about what people are. And it had nothing to do with changing people's genes. So that even though there was, apparently, this genetic component to slavery, it had nothing to do with changing people's genes to remove the slavery. So too then, with unhappiness. It might very well be solved, the chronic unhappiness or depression, might very well be solved no matter what the genetic component is, if we can recognize what happiness actually is. If it is actually about being able to solve one's problems once they're identified. Of course, we have no scientific theory yet, but the conjecture here and now is, of course, that happiness is about being thwarted in your problem solving. Okay, now continuing with the book. At this point, taking the step from heritable to genetically determined, the explanationless psychological study has transformed its correct but uninteresting result into something very exciting. For it has weighed in on a substantive philosophical issue, optimism, and a scientific issue about how the brain gives rise to mental states such as qualia. But it has done so without knowing anything about them. But wait, say the interpreters, admittedly, we can't tell whether any genes code for happiness, or part of it. But who cares how the genes cause the effect, whether by conferring good looks or otherwise? The effect itself is real. The effect is real, but the experiment cannot detect how much of it one can alter without genetic engineering just by knowing how. That is because the way in which those genes affect happiness may depend on knowledge. For instance, a cultural change may affect what people deem to be good looks, and that would then change whether people tend to be made happier by virtue of having particular genes. Nothing in the study can detect whether such a change is about to happen. Similarly, it cannot detect whether a book will be written one day which will persuade some proportion of the population that all evils are due to lack of knowledge, and that knowledge is created by seeking good explanations. If some of those people consequently create more knowledge than they otherwise would have and become happier than they otherwise would have been, then part of the 50% of happiness that was genetically determined in all previous studies will no longer be so. Pause there, my reflection. Okay, so the explanationless study that might suggest that, for example, genes code for 50% of happiness could be conferring that effect by good looks. By those genes might cause people to look a certain way. And so if those people are considered good looking because of the fact they've got these particular genes, then because they're treated better in society because of the fact that they're better looking or considered to be better looking, then this is the way in which the genes affect the good looks, which then cause people to be happier. And so we skip the good looks bit and we just go, well, the genes cause the better happiness. But as David says there, good looks is very much a cultural thing. And we know this. You just look at different cultures around the world and what they consider good looking. We only have to go back to the Middle Ages, and of course, people who were very large and obese were considered better looking. Today, people apparently who are far more thin are considered better looking. So there is absolutely a cultural component to what is considered to be good looking, which, by the way, should give you pause for a moment. When you consider that you're attracted to someone or you have an attraction towards someone, you might think that this is very much a genetically determined thing, that you feel this way and have absolutely no choice in the matter. However, if you have absolutely no choice in the matter, if it doesn't have anything to do with what you know about reality, then this would mean that the genes that code for how attractive you find someone are predetermined. But we know that the genes between the Middle Ages and today haven't changed that much in that way. We know, for example, that we can take a person who is perhaps would have otherwise been born into a culture that considers people with extremely long necks attractive and raise them in a culture where length of neck has absolutely nothing to do with attractiveness whatsoever. And their mind about what they find attractive will have been changed. Not because the genes have changed, but because their ideas about what is attractive has changed. So it's very much to do with ideas, and not inborn ideas either, I would argue. Okay, continuing with the book. David writes, the interpreters of the study may respond that it has proved there can be no such book that can convince people that all evils are due to a lack of knowledge. Certainly none of them will write such a book or arrive at such a thesis. And so the bad philosophy will have caused bad science, which will have stifled the growth of knowledge. Notice that this is a form of bad science that may well have conformed to all the best practices of the scientific method. Proper randomizing, proper controls, proper statistical analysis, all the formal rules of how to keep from fooling ourselves may have been followed. And yet no progress could possibly be made because it was not being sought. Explanationless theories can do no more than entrench existing bad explanations. It is no accident that in the imaginary study I have described, the outcome appeared to support a pessimistic theory. A theory that predicts how happy people will probably be cannot possibly take into account the effects of knowledge creation. So, to whatever extent knowledge creation is involved, the theory is prophecy and will therefore be biased towards pessimism. Behavioristic studies of human psychology must, by their nature, lead to dehumanizing theories of the human condition. For refusing to theorize about the mind as a causative agent is the equivalent of regarding it as a non-creative automaton. Pause there, my reflection. Now, I could go on for hours about this particular thing. It's such an important point. The link that David makes here between the mind as a causative agent and also as being creative. The link between creating something and causing something to happen. To create new knowledge is to create new possibilities in the world that were not there before. That means once we've got these new possibilities in the world, because we've created some new knowledge, so once we've got the knowledge of nuclear fission, for example, then we've got the possibility of creating electricity via nuclear fission reactors. That possibility did not exist before. We didn't have the choice about creating electricity via that mechanism. So the creation of knowledge has created new choices in the world. It has caused new ways of producing electricity in the world, let's say. So again, to create new knowledge is to create new possibilities, which means new choices, and acting on those newly created choices means causing events in the world that would not otherwise have happened without that knowledge creation. And this take on the nature of mind is, so far as I know, unique. David's overarching theory of knowledge really is this breathtaking worldview encompassing how knowledge grows at the level of a civilization, how it's growing here on Earth right now, how it does have and will continue to increasingly have cosmic significance, and how it will increasingly have cosmic significance, and how it can be invoked to explain the nature of personhood, which is what we're going through here now, and how it is that we distinguish persons from other kinds of life in the universe, especially other animals. And to bring this full circle, why therefore persons are themselves important in the cosmic scheme of things. It's all about knowledge and the mechanisms by which knowledge is created. And when that knowledge is created, how it causes the world to increase the number of possibilities open to people. And so this is the sense in which I would invoke free will, because free will is just another synonym for what's going on here. The creation of knowledge, which causes us to have more choices in reality, and those choices in reality will only be there once we've made the choice to create the knowledge. And if we continue to create more knowledge, then we continue to have more choices, more possibilities, and we'll be more free to do more different things. If we don't create knowledge, then we have fewer choices, we have less freedom, which means we're also in more danger. So increased knowledge means solving problems and preparing for the unknown, preparing for problems yet to be encountered. The more knowledge we have, the more wealth we've created, and the more we're able to solve problems as yet unencountered. Okay, but back to the book. The behaviourist approach is equally futile when applied to the issue of whether an entity has a mind. I have already criticised it in Chapter 7 in regard to the Turing test. The same holds in regard to the controversy about animal minds, such as whether the hunting or farming of animals should be legal, which stems from philosophical disputes about whether animals experience qualia analogous to those of humans when in fear and pain, and if so, which animals do. Now, science has little to say on this matter at present because there is yet no explanatory theory of qualia, and hence no way of detecting them experimentally. But this does not stop governments from trying to pass the political hot potato to the supposedly objective jurisdiction of experimental science. So, for instance, in 1997, the zoologists Patrick Bateson and Elizabeth Bradshaw were commissioned by the National Trust to determine whether stags suffer when hunted. They reported that they do, because the hunt is grossly stressful, exhausting and agonising. However, that assumes that the measurable quantities denoted there by the words stress and agony, such as enzyme levels in the bloodstream, signify the presence of qualia of the same names, which is precisely what the press and public assumed the study was supposed to discover. The following year, the Countryside Alliance commissioned a study of the same issue, led by the veterinary physiologist Roger Harris, who concluded that the levels of those quantities are similar to those of a human who is not suffering, but enjoying a sport such as football. Bateson responded accurately that nothing in Harris's report contradicted his own, but that is because neither study had any bearing on the issue in question. This form of explanationless science is just bad philosophy disguised as science. Its effect is to suppress the philosophical debate about how animals should be treated by pretending that the issue has been settled scientifically. In reality, science has and will have no access to the issue until explanatory knowledge about qualia has been discovered. Pause there, my reflection. So I riffed on this particular passage in my article titled Humans and Other Animals and the Ethics of Eating Meat, and you can find that on my website. Just Google my name, Brett Hall, Humans and Other Animals. And precisely on this point here about how one can study stags being hunted and find that certain enzyme levels are raised in their bloodstream. And this is supposed to be an indication that the fact that they're suffering while being hunted, that they're afraid, and so the enzyme levels rise, and so these enzyme levels are proof positive somehow that these stags are suffering. Yeah, so it's proof positive supposedly. They said that the hunting is grossly stressful, exhausting, and agonizing. Why? Because the levels of this particular enzyme were raised in their bloodstream. But another study said that a human could have high levels of these enzymes in their bloodstream if they were doing a sport such as football. And so this is a problem, isn't it? On the one hand, we have this exertion causing high levels of this enzyme in the animal, and this exertion causing high levels of this enzyme in a human being. But in the case of the human being, presumably they're enjoying this activity. How do we know that the stag isn't enjoying this activity? Well, again, that begs the question as to what it would mean for a stag to enjoy something in the first place, and whether or not they have the capacity to enjoy something in the first place. And this is something that I try to explore in my particular piece. And in that piece there, I'll just read. It's a very long piece. I'll just read a small part of it, where I've written, consciousness is central to our concern about the possibility that other creatures experience pain. Let us concede for the sake of argument that what they do feel we might term pain. But this would be very much like if we knew they were capable of experiencing blue. Knowing that another person is experiencing blue tells us very little about the contents of that experience. Are they seeing the sky, the blue mosque in Turkey, a policeman's shirt? Far more information than blue is perceived would be required to give us an idea of what that experience might be like. We would need context. We would need an entire explanatory theory about what that blue might be like, and it would take us into circles about, can they see shapes? And do they understand the relationship between those things? And do they realize that the sky isn't even a physical thing? Unlike what the ancients thought. They thought that the blue sky was like blue paint on glass. They thought it was a surface. They didn't know that what they saw didn't actually exist. And so it is with pain, really. Even if we have an excellent cause and effect explanation of the physiology of how the stimulus we call pain is transmitted to a brain and what might cause it to arise and what other stimuli, like say hormones being released into the bloodstream, absent further information we know very little about how the pain might be interpreted. That is to say, even if we can describe the objective physical goings-on in the nervous system, this tells us nothing about the subjective experience of pain. For example, the very same signals might mean that a person is exercising and enjoying pushing through the pain or some such, or perhaps a person is partaking in jiu-jitsu and the pain is a necessary part of the learning, and so an objective good. Or perhaps the person is suffering a heart attack, or perhaps a person simply doesn't even understand what the sensation is, and so on and so forth. Okay, so that's end quote for my little blog post thing, but if you're interested in more about this, this way of looking at the issue, the important issue of whether or not animals suffer, and all the very many related issues surrounding this. Is it ethical to eat meat, for example? Should we be able to milk cows, etc., etc., etc.? Some people have very strong opinions on this. Now, that's all very well, but to talk about the science of this, we have to be very disciplined, because there are no scientific studies that show animals experience pain, much less that they suffer. All that we have are proxies, and they might not even be proxies for pain. Saying that particular enzyme levels are an indication of pain is untrue or not possible to conclude until such time as we have a scientific theory of what pain is. And we probably won't have that until we have a scientific theory of what consciousness is. So I'm just going to steal David's thunder a little bit here for what is to come. What he's talking about now is the importance of, indeed the centrality of, to a large extent, errors in the process of science. Being able to report on your errors, your uncertainties, the sources of error, how to quantify your uncertainties. And if you're not careful about this, you're going to end up making false conclusions. Whole areas of the physical sciences, in physical science courses, at high school, at university, are devoted to error analysis. I'll put up on the screen here a section from a particular high school syllabus about error analysis. You can see here it's quite large. Sources of error are a crucial part of the methodology of any scientific study. And in physics, we have the special capability of being able to quantify our degree of uncertainty to some extent. Now, this is not uncertainty in sort of the epistemological sense. This is uncertainty in the measurement sense. So when we've got a measuring device that is able to measure to a certain precision, or a particular technique that measures to a certain precision, we report that. We say that we could be out by this much or that much. Back to the book. Another way in which explanationless science inhibits progress is that it amplifies errors. Let me give a rather whimsical example. Suppose you have been commissioned to measure the average number of people who visit the City Museum each day. It is a large building with many entrances. Admission is free, so visitors are not normally counted. You engage some assistants. They will not need any special knowledge or competence. In fact, as will become clear, the less competent they are, the better your results are going to be. Each morning, your assistants take up their stations at the doors. They mark a sheet of paper whenever someone enters through their door. After the museum closes, they count all their marks and you add together all their counts. You do this every day for a specified period, take the average, and that is the number you report to your client. However, in order to claim that your count equals the number of visitors to the museum, you need some explanatory theories. Pause there, just my comment. This is Popper's idea of observation being theory-laden. You first need a theory of what to observe and how before you can start making claims about what those observations might tell you about reality. Back to the book. For instance, you are assuming that the doors you are observing are precisely the entrances to the museum and that they lead only to the museum. If one of them leads to the cafeteria or to the museum shop as well, you might be making a large error if your client does not consider people who go only there to be visitors to the museum. There is also the issue of museum staff. Do they count as visitors? And there are visitors who leave and come back on the same day and so on. So you need quite a sophisticated explanatory theory of what the client means by visitors to the museum before you can devise a strategy for counting them. Pause there. My reflection or commentary. So already we see this quite profound yet simple point that it's not a simple process in science of going out there and observing the world. This is why empiricism is wrong. Observations do not come first, cannot possibly come first. You first need an idea about what to observe and how. And sometimes even something as simple as counting stuff, in this case counting visitors to a museum, is going to require an entire structure of theory in order to account for what you're trying to figure out in the world. So the theory comes first, and then the observations, and then the decision between the theories that you're trying to test with those observations. Okay, back to the book. Suppose you count the number of people coming out as well. If you have an explanatory theory saying that the museum is always empty at night, and that no one enters or leaves other than through the doors, and that visitors are never created, destroyed, split or merge and so on, then one possible use for the outgoing count is to check the ingoing one. You would predict they should be the same. Then, if they are not the same, you will have an estimate of the accuracy of your count. That is good science. In fact, reporting your result without also making an accuracy estimate makes your report strictly meaningless. Just my comment on that. Accuracy estimates are commonplace in physics. They are absolutely routine. Not every other area of purported science can make the claim that physics does in being able to quantify its uncertainty, or doing as well with uncertainties as what physics does. One area I know a little bit about is astrophysics, and a huge deal is made about errors and areas of uncertainty and what could have gone wrong, and there's always hedges and caveats about all the ways in which the observations which purport to show something could in fact be something else entirely, or not even actually real. One reason for this, of course, is that the amount of light we receive from distant parts of the universe is very, very, very low intensity in some cases. And so we are observing things at the very limit of the power of our instrumentation. But despite that, we have extremely precise instruments. But with extremely precise instruments come quantifiable uncertainties. You know how good your instruments are, and you report that as part of your experimental report, as part of your journal article, so that people reading it know that this might not be a real effect for various reasons. You might report things like the physical attributes of the telescope, the resolution of the telescope, and then you might report things like how bright the object was that you supposedly observed. And then the reader can gauge whether or not the thing being observed, the thing thought to be observed, might in fact be noise in the background, might not actually be a real effect at all. They can judge that by having a look at the sources of uncertainty, the sources of error that might be going on with that report. Now, in psychology, we might wonder, is there the same level of detail and strict adherence to some extent, strict adherence to the methodology of science in this respect, of genuinely trying to report all the things that might have gone wrong, all the areas of uncertainty, all the ways in which the result, the purported result, could in fact be a huge error and not real at all. Okay, so skipping a little bit and going back to the book. Now, suppose you are doing your study using explanationless science instead, which really means science with unstated, uncriticized explanations, just as the Copenhagen interpretation really assumed that there was only one unobserved history connecting successive observations. Then you might analyse the result as follows. For each day, subtract the count of people entering from the count of those leaving. If the difference is not zero, and this is the key step in the study, call that difference the spontaneous human creation count if it is positive, or the spontaneous human destruction count if it is negative. If it is exactly zero, call it consistent with conventional physics. Okay, pause there, my reflection. So this is great. So what David's driving home here is the point that if you're not being careful in your study about the sources of error, and therefore not being careful about things like counting visitors to a museum, and you're doing things like counting the number of people going into the museum and the number of people going out, but you're making mistakes. This is why earlier on he said the less reliable your assistants are, the less good they are at counting, the better for your study. Because if they're really poor at counting, they might miss some people coming in, they might add some people going out, and therefore people are apparently, according to your very careful scientific study, are being spontaneously generated. And so you can have a paper written about this new kind of physics. And so this, by the way, is a criticism of explanationless science and of just general bad science, which is explanationless science in large part. And we get this, I don't want to say all the time, but more frequently than what it should happen. And the softer the science becomes, the worse it can be. Not unheard of in the hard sciences, not by a long shot. There are errors that are made in physics. There are errors made in chemistry. For anyone that's interested in one of the most famous errors is, of course, the cold fusion debacle. You can go and look that one up, which I've mentioned in this series before. So errors can be made. And in the case of the cold fusion debacle, of course, it was indeed the case that the poor results were reported as being not consistent with conventional physics. So that's a rather boring thing when you're consistent with conventional physics. But if you're making errors, then you can make these grandiose claims that something about your findings, in fact, violate well-known laws of physics. And so we might wonder, we can always bet on these things, by the way, whether or not the result of a particular study, which purports to violate some conventional law of physics, is itself true, whether that's likely. A long-standing law of physics that so far has no violations has in fact been violated by this study, or in fact the study is just making huge errors, making some error somewhere or other. And so you always have that choice to make. Now it can always be the case that conventional physics is being violated in various ways, that we're wrong about what we know about the laws of physics. In fact, as Popperians, we know that we're wrong about the laws of physics because, well, knowledge is infinitely improvable, and so whatever we know about the laws of physics right now will be riddled with misconceptions, and we will correct those misconceptions. We'll come to have a better, deeper understanding of the laws of physics. So we know that the laws of physics as we understand them now is not the final word. But this is not to say that tomorrow when Professor so-and-so says that the study that they've just recently done has shown that neutrinos are traveling beyond the speed of light, that therefore shows that the theory of general relativity, which thus far has had no violations, so far as I know, as thus far there's been no experiments to show that physics in any way is inconsistent with the theory of general relativity. But if some professor comes along tomorrow and writes a paper about how neutrinos are violating the theory of general relativity by traveling faster than the speed of light, then we've got a choice to make. Is it in fact the case that this is an experiment which makes general relativity problematic? Or is it the case that the professor and their team have simply made an egregious error? And in fact, if you go back and look at the history of that particular one, which happened at the Large Hadron Collider, or involved the Large Hadron Collider, you can find that in fact the neutrinos never did travel faster than the speed of light. It was an error, and David's talked about that in The Beginning of Infinity as well. Okay, back to the book. The less competent your counting and tabulating are, the more often you will find those inconsistencies with conventional physics. Next, prove that non-zero results, the spontaneous creation or destruction of human beings, are inconsistent with conventional physics. Include this proof in your report, but also include a concession that extraterrestrial visitors would probably be able to harness physical phenomena of which we are unaware. Also, that teleportation to or from another location would be mistaken for destruction, without trace, and creation out of thin air in your experiment, and that therefore this cannot be ruled out as a possible cause of the anomalies. Pause there, my reflection. Now, why would you do this? Well, of course, to get media attention, because you're hungry for fame. You want to be famous. Scientists are not immune to this. Far from it. Far too often we see scientists who are desperate for fame and will say and do next to anything to get in front of cameras. Now, there are kind of legitimate reasons why. They want some funding. And there are illegitimate reasons, one might say, why they would do this. Simply because they crave prestige, or in worst cases still, authority. They want to be able to have the ear of government by being a famous scientist who has discovered something remarkable in the world. And so they become mini celebrities and they earn money and so on and so forth. So scientists are just human beings. Lots of people have these foibles and these flaws. But here's the way that a scientist might go about doing that: by making mistakes, or perhaps in some cases lazily making mistakes, in which case they're simply incompetent, or knowingly, in which case they're fraudulent, making these errors so that they can then claim, meekly and mildly, that perhaps it's the case that they've discovered evidence for alien life, but they don't want to quite say that. Okay, so I'll just continue reading. When headlines appear of the form, teleportation possibly observed in city museums, say scientists, and scientists prove alien abduction is real, protest mildly that you have claimed no such thing, that your results are not conclusive, merely suggestive, and that more studies are needed to determine the mechanism of this perplexing phenomenon. You have made no false claim. Data can become inconsistent with conventional physics by the mundane means of containing errors, just as genes can cause unhappiness by countless mundane means, such as affecting your appearance. The fact that your paper does not point this out does not make it false. Pause there, my reflection. Okay. There is a wonderful technique for detecting extrasolar planets, planets beyond our solar system. And it is by using the technique of finding solar systems beyond our own where the alignment of the planet just happens to be such that it passes between us and that other star. And so if this is the star, then the planet can come in front of the star. And that eclipses part of the light from the star. And given the precision of our instruments now, given how good our telescopes are and various other techniques that we use for analysing the light that the telescopes gather, we can determine what the size of the object is that's going around that star. We look at what's called dips in the light curve. Okay, what's that got to do with this? Well, recently, over the last 10 years or so, I think the most famous example is referred to as Tabby's star. That's Tabby, T-A-B-B-Y, I think. And now it's named after an astronomer who found this star where the dips in the light curve could not be explained by conventional astronomy. And it didn't seem as though what was orbiting the star, apparently, was a planet in the usual sense, or it didn't seem to be a binary system. And every single reasonable explanation that the astronomers could come up with was ruled out by observations that were made. Now, I'm certainly not implicating the astronomer in question here in this at all whatsoever, but the media are prone to putting forth the notion things like, Well, could it be alien technology? Could it be an alien civilization that is causing these weird dips? As soon as someone reputable makes that kind of claim, and they need not be a scientist, they could just be a science popularizer of some sort and saying, well, we don't have any explanation for what's going on, and astronomy is rife with these kind of things, where because we're looking at things we don't always understand, some people are going to disingenuously claim that because we don't understand the observation we've made, that therefore it's evidence of alien intelligence. Now, it could be, but that's a general purpose response to almost any weird observation we can make of deep space. And so in the case of this star, it was immediately latched onto as being proof positive, or near proof positive, that there was indeed an alien civilization that had created some huge structure. There is actually this theoretical thing named after Freeman Dyson. I think Freeman Dyson came up with it, called the Dyson sphere. And the Dyson sphere is theorized to be an alien structure. It would be an alien structure, a structure built by aliens of the far distant future to capture all the light that is being emitted by a star. If you wanted to really be efficient and not lose any of the energy coming from a star because you have super advanced technology, and you want to capture lots of the light coming from the star because you're powering some time travel device or whatever, which requires you to warp space and time. Maybe you put an entire sphere of material around the star to capture all of that energy. Now, if you're only partway through constructing such a Dyson sphere, maybe what Earthlings would see when they point their telescopes towards your star with the partially completed Dyson sphere is something like the light curve of Tabby's star. Okay, yeah, that's a really fun, interesting explanation, and certainly almost straight away the people involved in the study became quite famous, at least in the science community and the science appreciation community, I suppose. So I don't know what the solution is to that now, or if indeed they have a solution, but it can always be the case that it is observational error. And that doesn't mean that the astronomer themselves necessarily made a mistake, although that can certainly happen. It can just be that the equipment has malfunctioned in some way, which is what happened, by the way, with the Large Hadron Collider and the neutrinos experiment. Well, effectively it was an equipment malfunction. The cables were disconnected or something or other. Okay, let's go back to the book. Okay, I'm skipping a little bit. And David's talking about this study where people are apparently disappearing or being created spontaneously. And he writes, you know, if you're doing the study, you're the person doing the study, for all you know, they, the people, could be disappearing in puffs of smoke or in invisible spaceships. That would be consistent with your data, but your paper takes no position on that. It is entirely about the outcomes of your observations. So you had better not name your research paper Errors Made When Counting People Incompetently. Aside from being a public relations blunder, that title might even be considered unscientific according to explanationless science, for it would be taking a position on the interpretation of the observed data about which it provides no evidence. In my view, this is a scientific experiment in form only. The substance of scientific theories is explanation, and explanation of errors constitutes most of the content of the design of any non-trivial scientific experiment. Pause there, my reflection. And this is where we come really to so much of what is done in various areas of psychology. If you're only finding correlations between things, as happens in much of academic psychology, you're not explaining why one variable is correlated with the other. You might be insinuating that one thing causes the other, and in certain areas of psychology, let's say evolutionary psychology comes to mind, the correlation is implied so strongly that the practitioners seem to assume it is a causation. That this population of people here has this set of genes in common, and that same population of people with that set of genes in common tends to have this feature of their personality or mental life and so on also in common. And so it is a very small leap to say that the genes are causing the behavior in these people. That the genes are causing happiness, the genes are causing depression, the genes are causing this, that, or the other, The genes are causing intelligence. The genes are causing a propensity for mathematics or for music, and so on and so forth. That all of these mental features of a person are somehow conferred on them, at least in part, by the genes. But there's no explanation made as to how the genes can actually cause certain things. Now, I think in some areas of evolutionary psychology, people try to come up with explanations, but I don't think they're very good explanations. I must concede, it might be the case that genes do indeed cause, let's say, a propensity for an interest in mathematics. It's possible. But thus far, the explanations that have been put forth in order to link some set of genes with tendency to be good in mathematics are very weak indeed. But so many people simply assume it's part of the social fabric almost in the Western world that some people simply are born good at mathematics and some people simply are born bad at mathematics. Repeat for music, repeat for languages, repeat for any other quality of the mind that you like. And so many people have been taught to be genetic determinists, that if someone at the age of 5 doesn't show an interest in some particular subject, that they therefore lack the capacity to ever have an ability in that subject. And that is simply false. But our worldview here denies that possibility because of the idea that we have of the human mind as being this universal explainer. And universal means that it can actually do anything that anyone else can do. And there might be differences in speed and how fast a person can think and how much they can remember, and that may have a bearing of some sort. But it's hard to imagine that that would explain everything, and that all of the people who are good at mathematics in the world share the same clock speed of their brains or share the same ability to remember. In fact, that doesn't seem to be the case. But I'm traveling down an avenue that is a dead end for the purpose of this chapter. So let me reverse and go back to the book. And David writes, speaking about the counting study, the counting people at the museum, he writes, as the above example illustrates, a generic feature of experimentation is that the bigger the errors you make, either in the numbers or in the naming and interpretation of the measured quantities, the more exciting your results are, if true. So without powerful techniques of error detection and correction, which depend on explanatory theories, this gives rise to an instability where false results drown out the true. In the hard sciences, which usually do good science, false results due to all sorts of errors are nevertheless common. But they are corrected when their explanations are criticized and tested. That cannot happen in explanationless science. Pause there, my reflection. Obviously, it can't happen in explanationless science because we don't have an explanation of the meaning of the data. What the theory is explaining why this set of data is linked to that set of data. We don't have an explanation of all the sources of error that might be involved in collecting the data and analyzing the data. It's simply explanationless. All we're doing is collecting data, naively and in utter ignorance of the mechanisms by which that data might be an error. Okay, back to the book. Consequently, as soon as scientists allow themselves to stop demanding good explanations and consider only whether a prediction is accurate or inaccurate, they are liable to make fools of themselves. This is the means by which a succession of eminent physicists over the decades have been fooled by conjurers into believing that various conjuring tricks have been done by paranormal means. Bad philosophy cannot easily be countered by good philosophy, argument and explanation, because it holds itself immune. But it can be countered by progress. People want to understand the world no matter how loudly they may deny that, and progress makes bad philosophy harder to believe. That is not a matter of refutation by logic or experience, but of explanation. If Mark were alive today, I expect he would have accepted the existence of atoms once he saw them through a microscope, behaving according to atomic theory. As a matter of logic, it would still be open to him to say, I'm not seeing atoms, I'm only seeing a video monitor, and I'm only seeing that theory's predictions about me, not about atoms, come true. But the fact that that is a general purpose bad explanation would be borne in upon him. It would also be open to him to say, very well, atoms do exist, but electrons do not. But he might well tire of that game if a better one seems to be available. That is to say, if rapid progress is made. And then he would soon realize that it is not a game. Bad philosophy is philosophy that denies the possibility desirability, or existence of progress, and progress is the only effective way of opposing bad philosophy. If progress cannot continue indefinitely, bad philosophy will inevitably come again into the ascendancy, for it will be true. And that's the end of the chapter. So just that last sentence there. If progress cannot continue indefinitely, so if there is some actual cosmic limit on our ability to make progress, and many people who have not encountered the work of David Deutsch, in other words, the vast majority of the world so far, unfortunately, many people do have this idea, even people who purport to call themselves optimists, by the way, but not in the Deutschian sense, not in David Deutsch's sense. Some people who claim to be optimists nonetheless think there must be an actual limit on how much progress people can make, on what we can actually achieve in this universe. Now, David Deutsch's vision is the counter to that. It says that the only limit is what the laws of physics impose. Everything else is just a matter of creating the knowledge, and creating the knowledge in time, of course. But this is not a logical proof that there might not be a limit to progress, even though we say, according to our explanations, that there is no such limit. If there was a limit, however, then this would mean that progress would end. If progress ends, then it must be the case, therefore, that bad philosophy is actually true. Why? Because bad philosophy is that set of ideas which says why progress cannot continue, or should not continue, or will not continue. Or in other words, as David says right at the very end of the chapter, it's philosophy that actively prevents the growth of knowledge. So it's quite a scary thought, really. But happily, as optimists in the David Deutsch sense, we know that progress will continue indefinitely, that there is no such limit to producing more and more knowledge and in solving our problems. The only thing that is preventing us from making ever faster progress is our choices. That's convenient. That's precisely what the next chapter is all about. So I'll see you there in chapter 13. Choices. As always, thank you to everyone who is supporting Talkcast and my work here. I have a Patreon account. In fact, I think you can just type in Talkcast Patreon into Google and it should come up. There's either that or there's a PayPal link on my webpage as well. Thank you for all your support. See you next episode.